What are ontologies? Since ontologies are a very broad topic, in this video we will explain ontologies for use cases from catalysis research. Before we dive deeper into these particular topics, let's focus on the basics of ontologies. The word ontology describes the physiological study of being, or the modeling of knowledge. Ontologies represent knowledge in a web-like structure called the resource description framework, where it is modeled by simple associations. All these associations are built in a simple sentence-like structure consisting of subject-predicate-object relations. These subject-predicate-object relations allow a variety of ways to model knowledge, and therefore help us connect information in the form of data. In NFD I4CAT, we use ontologies to model knowledge related to catalysis research. Or we can easily store and model the relation iron catalysis-Haber-Bosch synthesis as a subject-predicate-object relation in a machine-readable form. But ontologies have something up their sleeves that is even better. They can be used to derive knowledge, even knowledge that is hidden from us. This is done in a process called reasoning. A small example of this will be given in the following. Let's assume we have a new catalyst called catalyst number 1, which was developed by a researcher in the laboratory. It consists mainly of iron and has been researched for denox processes. These are processes for removing nitrogen oxides, for example from exhaust gases. However, the catalyst only has those components that are not considered catalyst poisons for the Haber-Bosch synthesis. The whole process is shown here. If the relation is present that a Haber-Bosch synthesis catalyst should consist of iron and must not contain catalyst poisons, the following relation can be drawn. Catalyst number 1 can also catalyze Haber-Bosch synthesis because it has iron as its primary component and does not contain catalyst poisons. The knowledge that emerged from this may not have been directly evident to the researcher, and especially not directly apparent for all reactions. If we use not only one relation, but several networked relations, we can potentially even assess how active this new catalyst number 1 is. The advantage here is that only new data was added to the ontology, and this generated knowledge automatically. For this, the ontology only needs to be set up once. But ontologies allow not only the pure extension by means of data, but should also be dynamic constructs. That is, if we add a new relation, alumina is active catalyst aid, in addition to the classes less active Haber-Bosch synthesis catalyst and active Haber-Bosch synthesis catalyst, we can classify our catalysts directly. In NFD I4CAT, we want to use this technology, among other things, on one hand to sort, classify, and describe data directly, and on the other hand, to give researchers direct access to this hidden knowledge and thus further support and accelerate research. However, all this cannot work without appropriate databases and repositories, as the ontologies are only the backbone of the structured data. For more information on databases and repositories, feel free to watch our video. Find more useful information on how we can help you or your organization, or support us. Ask us questions, or simply subscribe to our newsletter to stay in touch. Join us in shaping the data-driven evolution of catalysis. nfdi4cat.org